Today we're going to start with section 6.1, which starts chapter 6, and this is going to be law of sines. We start with law of sines, then we go to law of cosines, but instead of doing both together, we're going to separate them apart. And what law of sines does is we have triangles that are no longer right triangles. We're used to doing sine, cosine, all the trig functions with only right triangles, but now we're going to see that we can do those without a right triangle. For example, right here, it says, can you find the missing side? We're trying to find this side right here, but there's no right angles, so this is very different than what you're used to doing. Okay, so we're going to come back to this and we'll figure out how to do this here in a few minutes. So let's go look at some stuff here. It says you can still use the sine and cosines for oblique triangles, and oblique triangles is the word that they use for triangles that are not right triangles. To start with, you have to know at least 3 pieces of information. You have to know at least one side and then any other 2 pieces of information. When you know 3 pieces, it's going to fall into one of these 4 categories right here. Okay? First one is 2 sides and either angle that is not included in between the 2 sides. That would be your side-side angle. Any 2 angles of any side, angle, side, or angle, side, angle. And the last 2 would be 2 sides and the included angle, which is side, angle, side, or all 3 sides, which is side, side, side. For what we're doing today, we're going to only look at these first 2, which is your law of sines. That's what those first 2 fall under the law of sines, and the last 2 would be cosines. So we're only going to focus on the first 2 today. And the law of sines says if you take the sine of angle A over side A, that's got to equal sine of angle B over side B, which has got to equal sine of angle C over side C. Or if you want to round the other way around, it doesn't matter, you can do the reciprocals of those equations and do like that. So obviously you're not going to use all 3 at the same time, you're going to use 2 of them instead of proportion and be able to solve for your missing piece. Okay, so let's go look and see how this was going to work. Okay, for example number 1, we're going to start off with knowing 2 angles and the side that is included. So if I were to compare that to the 4 categories, that would be your angle, side, angle method that we have talked about. So that's going to fall into law of sines. So all I do is, when it says solve the triangle, by the way, you have to find all the missing pieces. So you have to find angle C, side A, and side B. So I'm going to start off by finding angle C, because that's going to be your easiest one to find to begin with. That's just going to be your 180 minus your 40 minus your 36, and that of course is going to equal 104 degrees. Okay, so I'm going to write my answers down here so they're nice and easy to find all in one place. 104 degrees. Then we're going to have side A, and then we're going to have side B. Okay, so now let's go on to the sides. So I'm going to go ahead and label that angle 104 over here. Now let's try to find a side. Let's start with side A. So I'm going to do sine of angle A, which angle A is 40 degrees. Divide that by side A, and then I'm going to do sine of angle C over side C. And we go ahead and do the cross multiplying. Sine of 72 sine of 40 is equal to A times sine of 104. And you want to make sure that your calculator is in degree mode when you're doing this stuff, so you don't get the wrong answers. And to get A by itself, you just simply divide both sides by sine of 104. And when you do that, I'm going to come up with A is about, let's put the about sign in there, A is about 47.7. Oops, give me a little bit better handwriting there. 47.70 inches. So A is about 47.70 inches. Okay, now let's go ahead and go to side B, we're going to do the same thing. We can still use this same part of the proportion right there. That's fine to use. So I'm going to say sine of 104 over 72 is equal to, now since we're trying to find side B, I'm going to use angle B, sine of angle B over side B, which is our variable. So again, crisscross them, multiply, sine of 104 times B is equal to 72 sine of 36. So you divide both sides by sine of 104 and write it all out there. And when you do that, you're going to get B is about 43.62 inches. So 43.62 inches. Now, even though that was an oblique triangle, we were able to find all the missing pieces to that side. Okay, now we're going on example number 2. Oops, excuse me there. And we're going to find the missing pieces again. And now this one, the side is over there, so this is going to be angle side. So it's going to fall into that same category of law of sines. So again, I'm going to write down my pieces I need to know. I need to know angle C. I need to know side A. And I need to know side C. So I'm going to first start off with angle A, because that's just the easiest. Oh, no, I'm sorry, angle C. Angle C would be 180 minus 20 minus 110, which of course, this of course is going to be 50 degrees there. Okay, so let's go to side A or side B. It doesn't really matter which way you go, but let me go ahead and label that angle C in there is 50. So let's just go ahead and do A first. So I'm going to do sine of angle A, which is 20 degrees, over side A is equal to, now the other one I know, how do I know which one to use for the second part? I always do the one that you know numbers for both, the angle and the side. So I'm going to do sine of 110 over 25. That way we only have one letter that's missing, one variable. So crisscross them. I'm sure you can do this without any problem now, because you've been cross multiplying for a long time. And divide both sides by sine of 110, and you're going to get A as 9.10. I'm going to round everything to the nearest hundredths. Okay, and meters is my units of measure, so that's meters. Okay, and moving on to the last piece, side C. Again, I'm going to use that sine of 110 over 25 as my starting piece, because that's the one I know the numbers to. And sine of angle C over side C. Crisscross them. 25 sine of 50. And go ahead and do, that should be abouts there. Sorry about that. Always forget to do that. These should be abouts because we're rounding. And C comes out to be about 20.38 meters. 20.38 meters. So those are the easy kinds of this. Now we're going to jump into the little bit more complicated ones. Now we are moving on to what we call the ambiguous case. When you have a triangle that falls into the category, that first category we said was side-side angle, and we have two sides, angle not included, we have what we call the ambiguous case. And it's kind of a pain because we have three different possibilities that can happen. We can have one triangle as our solution. We could end up doing everything and have no triangle because its piece is too short. Or you can end up having two triangles, which is all kinds of fun there. So let's just go ahead and scoot over to example number 3. And let's look at what happens when there is no solution, why there's no solution. So it says solve the triangle A equals 14. So what I'm going to do, I'm going to start off by drawing a quick little sketch out. My great wonderful triangle there. A, B, and C. Angle A is 14. I'm sorry, side A is 14, side B is 30, and the angle A is 80 degrees. Okay, that's what I'm going to start out as, but we're going to notice that one of these sides comes out to be just a little short, and our picture doesn't really match up. Okay, so let's see how this would happen. So knowing what we know about law of sines, so let's use sine of angle A, which is 80, over side A, which is 14. The other side we know is side B, so let's say sine of angle B over side B. Okay, and let's go ahead and crisscross them, cross multiply, divide by 14, equals sine of B, and that comes out to be about 2.11. Now whenever you're trying to find the angle, that's when your calculator you hit second sine, and when you hit second sine and type in 2.11, you're going to get an error message because your calculator can't do it. If you've ever noticed anything about sine and cosine, the values for sine and cosine, if you take the absolute value, it's got to be less than 1. So this guy right here, much bigger than 1, so I know that this is not possible. There's no triangle for this one. Okay, anytime you come up with something sine or cosine and it's bigger than 1, I just stop right there. Can't do it, not possible. Okay, so now we're going to look at the lovely two solutions of the ambiguous case. Okay, so let's start by getting to my pen here, and it says A is 13, B is 30, and angle A is 20. So knowing from my law of sines, I'm going to say sine of A, of angle A, over side A is equal to sine of B over my side B. Okay? And when you do all that, crisscross multiplying there, you're going to come up with sine of B is equal to 30 sine 20 over 13. So you're going to come out to be, angle B is about, let's see, 52.12 degrees. Okay. Now, this is where it starts getting a little interesting. Okay. If you remember from law or from the unit circle, sine is positive in quadrant 1 and in quadrant 2. So really this could be 52.12 degrees, or this is 52.12 degrees. So it can work for this angle, but it also can work for this angle right here, can't it? Okay, and since it can do that, that angle right there, if I do 180 degrees minus 52.12 degrees, that's going to give me my 127.88 degrees. And that is where I get my two different angles. Okay, so let's look at this and draw it out and see if we can cram everything in here. Okay, I'm going to switch back to purple here. This triangle right here, lovely triangles there. Sorry, I'm not using my straight edge, it's faster that way. 20, 52.12. Let's see if I can get that any smaller. 13. Whoops, that's bigger. 13 and 30. Okay, that would be this triangle right here. I'm going to call that my first triangle. Okay, so since I have that piece right there, that's one of the missing pieces. Okay, and since I know angle A is 20 and angle B is 52.12, I can figure out what angle C is real quick, couldn't you? When you do angle C, that's just going to be your 180 minus 52.12 minus 20, and that's going to give you your value of 107.88 degrees. Okay, there's angle C. Now, your side C, okay, that's the one we're going to find using the law of sines now. So this is going to be 107. This is going to be 107.88 here. Sorry, my volume got all messed up on my side there. 107.88, and if you do sine of angle A, or sine of angle A over 13 is equal to, and we're trying to find side C. Sorry, I'm having a little problem there with my computer. Over C. Okay. If we work all that out there, let me get my calculator. When you do that, you're going to come up with C is going to be 36.17, and we're talking about feet there, so I'm going to say that is 36.17 feet. Okay, so 36.17 feet. So there is your 3 pieces of information using this first triangle. Now the lovely thing about these is there's 2 triangles that are possible, because one is an acute triangle and then one could be an obtuse triangle over here. This would be your 127.88. This would be your 20 for your angle A. This is 13, and this is 30 down here. This is your angle C and angle B. Okay, so this was angle B. Is about that. So there's angle B. And if angle B is that, we can easily find angle C. Angle C is going to be 180 minus 127.88 minus your 20. And that's going to give you about, get my calculator, about 32.12 degrees. So there's your second piece of information. And now with the third piece of information, we can just go right into that. We can do, by using the law of sines now, sine of 127.88 divided by your 30 is equal to sine of 32.12, since we're trying to find side C, over side C. Crisscross them around, and you guys can do that on your own. You're going to get about 20.21. And we're talking about feet there. So then there is your third piece. So even though and I'll show you how to figure it out if it's going to be 2 or 1 solutions when we do the next one. Okay, but here we had 2 solutions. We had the acute angle triangle, and then we had the obtuse triangle. Okay, now we're going to go to example number 5, which is looking at the side-side angle, which is the ambiguous case, but having only 1 solution. And I'm going to show you how we can easily see when it's 1 solution versus 2. Okay, so what I'm going to do is, you can start by drawing the triangle if you want to, but I'm just going to start with using the law of sines. Let me change my color to something else there. So I'm going to do sine of 41 degrees over side A equals sine of angle B over 13. And you can do that, and you can solve that for sine of B. You're going to have 13 sine of 41 all over 21. So B comes out to be about 23.96. Okay, you know that's one answer for sure. Okay, now how do we go and check to see if we have another angle B like we did before? Well, the way we did it before, we said 180 minus whatever that is. Okay, if I did 180 minus 23.96, that's going to give me 156.04. That could be my other angle, but let's go back and look at the angle that they give us, 41. Okay, if I would add this second angle B to my angle that I already have, that's going to be 197.04. Now, can that make a triangle? Nope, it cannot. So that second angle is not going to work. Whenever it busts 180, you know it's not going to work. So, thankfully, we only have one answer to mess with this time. Okay? So it makes it nice when there's only one answer to deal with instead of two. So we have angle B, and now we can find angle C. Angle C is going to be 180 minus my angle A minus my 23.96. And when I do that with my handy dandy calculator, we get is about 115.04 degrees. So there's my second piece of information. And then we gotta find angle, or that was angle C, so now we're gonna find side C. So sine of A over A equals sine of C over C. And I'm trusting that you can do all that by now pretty easily. The cross multiplying, you're going to get 29.00 feet there. Okay? And that is how you do it. That's how you show that there's not two triangles possible, only one. Okay. Find the area of an oblique triangle. You've always been able to find the area of triangles if you know the base and height. That's a real easy one, but now that we're in pre-cal, we're going to make it a little bit tougher. So we're going to find the area of these oblique triangles with no right angles. Okay? You can get creative with these formulas of law of sines. And when you do that, you come up with these formulas that you see right here. It is 1/2 two sides and times that by the sine of the included angles. So it doesn't matter if you know side B and C and angle A, side AC angle B, or AB and angle C. It doesn't matter which way, it's all the same way. So let's see how this works. Go over here. Find the area of the triangular field with side lengths 24 and 115. So I'm just going to draw a quick triangle here. So 24, 115, and the included angle is 42. So I'm going to use the formula that we had. 1/2 times the side times that by the sine of the included angle. Okay, and again, just make sure your calculator is in degrees when you're doing this, and you're going to get, let's say this is the area. The area is about, let's round it to the nearest hundredths again, 923.4, and it is in meters, so that would be, since we're dealing with area, that would be square meters. And that's all for that one. Makes it kind of nice and easy there to wrap that up. So that is section 6.1, law of sines.